Hello, my name is Ryan Valera. This is my fourth project for Physics 120, Motion Feedback. The first part of this video will be me explaining my circuit. So as per usual, we have it hooked up to the computer using a USB. Here is our picometer, and there is a NeoPixel LED strip right here. And this is an IMU, which is responsible for acting as a sensor of a local magnetic field and an accelerometer. And we have our breadboard. So the connections that we have made so far is the picometer will be working as the power source for both of these. We plug it into the 3.3 volts thing. It will be plugged into our breadboard, as you can see. And then I have an extra wire taking it out into the inner workings of the breadboard, and then both the IMU, which is going to be the red wire, and the NeoPixel, which is also the red wire, will be gaining a voltage from the picometer. As you can see, voltage flows, goes through the wire, hits, goes into the NeoPixel, and then hits, goes into the IMU. The next thing that I will be talking about is the blue wires, or the blue wire for the NeoPixel strip. It is connected to the GP20 pin in the picometer, or the pico board. This will be allowing us to control which LED is lighting up in our code. We also have a ground for the NeoPixel, which is at the grounded part of the breadboard. And then same thing goes for the IMU. There is also a ground, which is right here. And then it will all feed back into the picometer, and as you can see, it is connected to the ground. The other two things that are going to be important in the circuit are the things that will allow us to get readings from the IMU, which are the SCL and SDA pins in the picometer. This is what is going to allow us to use and control the data from our IMU. So the next thing that I will be showing is why the thing is currently lighting up and why it is lighting up that color and everything else is dim. This is the first part of the project. This is implementing visual tilt feedback. So if we go to our code, we can see that what is being printed is the tilt angle. What this means is that with respect to parallel to the to whatever surface you are usually standing on. So for me, it would be a table. If we are completely parallel to the surface, that means in theory we should have a 0 tilt angle about the X, which it's not exact because of how the picometer reads, or the IMU reads, but it's pretty close and we can get it. It's pretty close. And as we can see, this is me trying to hold it parallel to my table, which corresponds to around 0 degrees, tilting about the x-axis. So this is our x-axis coming out this way, our z-axis is pointing upwards, and then our y-axis is pointing outwards to the right, as we can see from the definition on our IMU. The next thing that I will be showing is corresponding to the table that the professor gave us, which is right here. On the far left, this is going to be the far left LED, and so on and so forth if you keep going down using the same logic. If I rotate my IMU more, or orientate it in a different way, different LEDs should be lighting up corresponding to this table, which is what I will demonstrate now. So this is me around 0 degrees, or at least this is me attempting to try and do 0 degrees. And this is around the same. Anything from +5 to -5 is what LED we should be seeing. And that's about correct so far. And as I continue going up, we will see that it moves more and more left into the more positive, and then we'll reach around 180 degrees. We'll come back down, and then we will see a similar thing. And this is all being printed simultaneously at the tilt angle, which I will now demonstrate in our code. So as we can see, it is updating 180 degrees. It's very finicky, but it works well enough. And it prints from 180 degrees to the -180 degrees. So the next thing that I will be showing is me implementing turn feedback instead of tilt, which is going to be us rotating about the Z instead of the X. I was not able to get them both to work simultaneously. That's why I am copy and pasting the code like this. So you can also see that it is printing our turn angle, and using the same logic, this is the far leftmost LED. We will be following this table. So as we can see right now, this is supposed to be between -15 to +15 degrees to have all of them light up green. That is currently what is happening. But if I pick it up and I rotate it, we will see that it updates. And this angle here corresponds to us pointing fairly close to where the magnetic field actually is in true north. It's pretty close, all things considered. And I will show that my code is updating once again. So this is me making more blue LEDs turn on. As you can see. And then I will go back clockwise and increase it in the positive. And as you can see, red. And that is my project.